Now what we're going to do is we're going to look at growth and decay word problems. We've been graphing growth and decay functions for exponentials. Now what we're going to do is we're going to look at the word problems. We're going to be looking at our function y equals a b raised to the x. A is our initial value. That's what we're going to start with. And then b is going to be our rate. Now there's two different rates that we're going to look at. Growth rates are all rates over 1, and decay rates are always rates in between 0 and 1. So some of these are going to be percentages, and we kind of have to figure out what the actual rate is going to be because it's not as easy to just plug into the formula. We have to think through this a little bit. So with the first one, it says in 2010, there were 300 cell phone subscribers. So that's our initial value, y equals 300. That's our A value. The number of subscribers increases by 75%. Now, a lot of students, what they'll want to do is put 0.75. This is incorrect. And the reason why is this is increasing by 75%. Decay is in between 0 and 1, but growth has to be over 1. So our growth is 1.75. 1 means it stays the same whenever we multiply something by 1. Whenever it's increasing, it's always over 1, so it's going to increase by 75%, so that's 1.75. Now, this is after 2010. We're trying to figure out how many are in 2020. That's a difference of 10 years, so we raise it to the 10th power. That right there is going to give us 80,816.8. So we're going to round up and we're going to say 80,817 subscribers. Now, example 2. You bought a car for 20,000. So our 20,000, that right there is our initial amount. That's our A value. This is what we start with. So y equals 20,000. Then it says it depreciates by 8%. Once again, depreciate means that it's in between 0 and 1. So it has to be less than 1. Now the problem is, once again, a lot of students, what they want to do is they see the 8%, so they want to put 0.08. That's incorrect. The reason why is this is how much it loses. We're trying to think about the value of the car. How much is the car worth? So if it's losing 8%, then that means it's still worth 92%. What we're doing is we're subtracting the 8% or the 0.08 from 1. So from the whole number, remember 1 means it stays the same. So if it's depreciating by 8%, that means it's less than 1. So we're taking away the 8%. And then we see that it's for 5 years. So we raise it to the 5th. Now, when we're talking about finances, what we're doing is we're rounding it to the nearest penny. So we have $13,181.63. Okay, your grandpa bought a home in 1960 for $60,000. The value of the property increased by 5% each year. What's the value of the property in 2020? So once again, y equals, the house initially was $60,000. 5% increase means it's increasing by 5%. So hopefully all of you are thinking 1.05. Remember, if it's growth, it has to be over 1. Now, from 1960 to 2020, what we have is a difference of 60 years. And once again, this is a price, so we're going to round it to the nearest penny. And so what we get is $1,120,751.15. Now, example 4. In a small lake, there are 500 fish. Once again, this is our initial value. This is the beginning. So we have y equals 500. The population decreases at a rate of 3%. So once again, the mistake would be putting 0.03. That is incorrect. We're not trying to figure out how many fish died. We're trying to figure out how much fish are still in the pond or the lake. So we're taking 1 and we're subtracting 3%, and that's why we're getting 0.97. And we're trying to figure out after 8 years. So we raise it to the 8th. And then that gives us 391.87. And so we're going to round up to 392 fish.